We are here again with this. This is the WAEC 2025 likely questions. The questions are here, so do yourself a favor by just watching and then asking questions where necessary. So in this live stream, I'll be handling the answers to these questions and then also show you I'll live stream the experiment itself. It is easy. If you listen well and watch well, you will get the message immediately on what you are needed to do. In this case, you follow the order and then remember to ask your questions where necessary. Bring your questions, all your questions, I'll handle them. And then I advise you to read your questions in the question paper very well before providing their answers. It is a cheat or the easier way. So please, if you are live, you have to do one or two things for me. Just share this link so that we can discuss and do a final revision. How this will go is that, and then show experiment, because this is Sa Majesty's World Science Channel. We'll be handling the real life experiment. Both titration and salt analysis, they are all here. Okay, so remember, there are instructions they gave us that we neglect. You try to see these things, not all about don't the booklet. They say you are advised to write what is readable. So try to present your answers very well. It matters a lot. Even when you know what you're answering, you need to present it so that it will be readable to the marker. And I advise you, as you follow up, you are going to follow the rules for writing practicals. Okay, so I think if you are online, you say hi, let's know what next. Okay, over here is this is the salt analysis. I can see okay, you guys are okay. You're welcome. Victor Elochuku, you're welcome. Thank you. So when any question you are confused about throughout the whole thing, okay, Emmanuel Chukwemeka, thank you. I can see you guys. You're welcome. KG Wiseman, Oluwasin, Olajibu, you guys are wonderful. Please, let's make this class memorable. It's going to be a great day. Tomorrow, our exam shall be blessed, of course. Now, follow the instructions and they say C is a mixture. Famous farm. God bless you. I can see you guys. Let's get down to the business. Let's get back down to business. Okay. C is a mixture of organic and inorganic compound. Carry out the following exercises on C. Record your observations and inference drawn from the results of each test. You see the normal thing. They say with spatula, collect a small solid sample of C and hold in a non-luminous flame. So you can see the questions very clear. So what you're going to do is, of course, amen, God will do that. Adeto me. If I don't get your name well, please don't get annoyed with me. I'm trying my best, okay? So what matters is that this salt analysis has been treated in details. Please, what we are going to do now is, I encourage us to just do what now? You're going to just visit the Majestic tutorial for the salt analysis, but for the titration questions, I'll handle them here. So the Majestic tutorials, the video for the salt analysis is already there waiting. Okay, remember, I'll finish up this things. Your job is to ask questions, please. All right, so let's go back to the titration questions. That's where I will focus here. See what the titration question says. Remember to read the questions very well in the question paper before providing their answers. Olanusi Samuel, welcome. I can see your comments. A is a dilute solution of a monobasic acid. I want to correct an impression here. Don't say that you know what WAEC provided. Work with what you are given in the question paper. Work with the acid and the base you finally see in the question paper. So look at how this question is crafted. A is a dilute solution of a monobasic mineral acid containing 0.2 mole per dm cube solution. B is a solution of 0.095 mole per dm cube of a metallic triazocarbonate. Imagine, it's possible they gave us hydrogen carbonate and they are giving us triazocarbonate. It's possible they say provide 0.1 mole and they are bringing 0.5. Your job is to follow the steps. If you have ever seen WAEC marking scheme, there is nothing like this is the correct answer. Mike, Destiny, you're welcome so much. I can see you. So there is nothing like this the best answer. So that's what I'm advising against, trying to change figures. Then follow the rules of 3 significant figures in each one of the concentrations you are given. Then now say put A into a burette and titrate against 20 or 25 cm3 portions of B using methyl orange indicator. Repeat the titration to obtain concordant titers. So what you are required to do here, you are Joseph Okafor, God bless you. I can see you. So let's stay focused. In this case, just look at the following questions. Before you start solving, try to browse through the whole question. Put A into the burette and titrate against this methyl orange. This is the space where we make the table. So look at the follow-up questions. So the follow-up questions here is, after you have finished the table, you look at it very well. From your result and information provided, calculate the mole ratios of the acid to base. Okay. The next one say write the balanced chemical equation of the reaction. Chiamaka Collins, you're welcome. Write the balanced chemical equation of the reaction between A and B, because they did not give us equation in this reaction. So they say calculate the mass of carbon dioxide liberated from the reaction, and then other follow-up questions. So we are good now to go back to make our tables here. And in this case, permit me. So here, let me use think black will be okay. Or do we use blue? Maybe let's try blue and see how it goes. So endeavor not to cancel your table, because cancellation of table will attract the what? Penalty of losing some marks. At least not even blue. All right. So, as usual, I record your observation. Good evening, my dear. So please keep watching this and then ask questions where necessary. So I'll do the titration and the salt analysis here in this live stream. I mean the real titration and the real salt analysis, the analysis of glucose, and then together with copper 2 tetraoxosulfate 6. So to make your table, you always have you have your rough, your first, then second and third, and over here you make it for your burette reading. Endeavor not to cancel your table, please. And remember, the endpoint I'm going to use here should not surpass the one your school teacher is using. So you should be able to do your titration and know the endpoint exactly that your own school is getting. That doesn't mean we have the best endpoint, as I said earlier. For teachers, your job is to prepare what is consistent. So we have because the lines are not well because this picture was snapped. Okay, so here we have burette readings, and here we have final, which is in cm cube. Here we have our initial, which is also in cm cube. Then here we have volume of A used, right? Then on top of your table is necessary indicate volume of pipette used, say 25.00 cm cube. That is if you use 25. If your school is using 20, you write it there. Then rough, you can still put unit here, but one place is enough. If you have put cm cube here, there won't be any need of putting it again here. So rough, first, second, and third. All right, imagine me, I am doing the table. I'm reporting number 1 under number 2 question. Don't mind me. Okay, thank you. I even realized just now. So let me please let me go. Imagine, please let me go to that question. For this SWOT analysis, please, you visit Majestic Tutorials for that SWOT analysis. So thank you for, I realized that's when you reminded me. Please, this is where we need to do whatever we are doing, okay? Sorry for that waste of time. This is slated to last an hour, 13 minutes. We'll solve every question. Thank you, Mike Destiny. Thank you. Immediately I noticed the other live stream I was doing reverse. No, first reading cannot be seen as rough. Rough is different thing altogether. Just rough is what you do to know the range of the words and point. It's not it doesn't replace your first. Let me use blue here. I think this should be okay. I think because of a lot of time I've wasted, should I use freehand? Okay, let me be fast. Direct reading, rough. Remember, you can do first and second with your rough, or you do first, second, and third. Yes, rinse off the conical flask. I will do it during the live stream of the practical. You ask these questions, please. You see those things. You rinse off the flask with distilled water and not the base after each titration. Okay. Stay calm. Stay calm. Stoichiometry, can we use phenolphthalein? I said I will live stream the practical. You will see me doing it. I'll do the practical for you now, real life. So wait, let's finish this question. Let's manage our time, please. Yes, after the live stream, the video will be automatically saved. You just come back here, you will have access to the video, okay? So I like those of you coming up with questions. Okay, that's the reason for this live stream, because I'm attending to your questions immediately. Okay, we have burette readings. Okay, let me finish up. Final, initial, final, and volume of A used. Thank you, Alakunle. You're welcome. Burette readings. Here is our final. Nazareth Igwe, thank you, which is in cm cube. Here is our initial, which is also in cm cube. Then here is the volume of A used, which is also in cm cube. All right. Then here is our rough. If you like, you put units here. Here is our first, second, and third. So on top, you say volume of what? Pipette used. Please write in the color of the indicator and the color at endpoint. It doesn't really make sense because the question I've already instructed you using Metsi orange indicator, so there won't be any need of telling the person the indicator you use. You have been instructed to use such indicator. Okay, used is what? 25.00. Why must we write the volume of pipette used? Because we have in the question said, Desmond, welcome. The question said you have 20 and 25. So you have to specify the one you are using from the instruction given to you. Now, how to fill our table? If you do your titration, remember concordant titer values must be obeyed to score. If you don't have concordant titer values, you will lose mark. What are concordant titer values? Values that do not vary with plus or minus 0.1 or plus or minus 0.2 at maximum. Okay, so that's what we call concordant titer values. I think black is, I prefer using black, please. Now, the rough, in this titration, I'll be using 24.9. I want to use 24.90 here. And my rough, from the titration I did, I'm using the exact report from what I did, okay? 24.9, but my rough, I can't remember, and it is called rough, so I might do it 25. Maybe 30. Remember, initial is 0.00. Always keep in 2 decimal places. Okay. Then here is I got 24.9. I also got 25.1. So, but let me use 24.9 here. Sammy Morutala, you're welcome. You're welcome. So now you bring down this 25.30 and this. You don't understand what destiny. You just say you don't understand, but specify what you don't understand, please. Okay. Then the first, from what I got, I said I got 24.9. Welcome, Peterson. Chicken World. Welcome, Guru. You are Guru too. 24.90, 0.00, 24.90. Then what is here is let me use 25.00, 0.00, 25.00. Okay. I wouldn't say yes or no to that. Rough reading, I don't see any provision for that says compulsory or not. But normally, put it, please. I cannot give you wrong impression. Do you understand me? So now, the third, I got 25.1, even though it looks as if I'm increasing or decreasing down, but let's use that, 25.10. It is not a crime if you have the same endpoints with your teacher. That shows maybe you're an expert. But it becomes a crime when you cancel your table to go and rewrite your table to rhyme with that of the teacher, or you alter your table to rhyme with that of the teacher, okay? Then, so when I will live stream this thing, those people ask, I say I'm going to live stream the real experiment. Like you see me performing it in this live stream. So calm down with any question, okay? So gravity cation, serious cation. We have made our table. We now come here and say, Tope Odole, you're welcome. So we are going to look at this. Remember, to determine the average volume of A used, what is the average volume of A used? VA is equal to, first, second, and third are concordant. So you tell the marker, I'm using first plus what? Second plus third. Divide by 3. Okay. Auto finisher. So Chibuchi, we have to, if you use 2, you divide by 2. Like if I use first and second, I divide by 2. If I use third and second, I divide by 2. But if I use 3, I'll divide by 3. You cannot do less than 2 values. Don't use rough in determining your average volume of A. So in this case, what is my VA? It is 24.90 plus, you see how my table is, I didn't cancel anything, plus 25.10, all divide by what? 3. Princess Emanuela, welcome. So now 24.90, all this we got our what? From the calculator department, we will automatically get 24.9025, that's is the same thing as 25 at the end. That means we are getting 75 in total. Yes, so this is 75 divided by 3, which is what? 25.00 cm cube, your answer. So you are done with this question. So we are going to go and continue with the other follow-up questions. All right, the other follow-up questions. So the follow-up says, from your results and the information provided, whenever you meet this question, always remember the information provided. For me, I think, do I still remember what they say A is? So I have to go back and remember the information, please. What do A is a dilute solution of monobasic acid. So they say 0.2 mole for A, then 0.095 for B. Correct, okay? 0.2 for A, 0.095 for B. So here we move. So looking at this, you bring out this 0.2 mole per dm cube. What? 0.2 mole per dm cube, a monobasic what? Acid. So we can simply say HX as the monobasic acid, and B is 0.095 mole per dm cube, a metallic trioxocarbonate. So we can decide from your results, calculate the mole ratio of the acid to the base. I want us to note something here. The mole ratio of the acid to the base here is remember we have the formula that says CAVA all over CBVB equals NA over what? NB. So which means for you to know the mole ratio of acid, you have to multiply what? You have to multiply concentration of acid by the volume of acid used. For you to know the mole ratio of base, you have to multiply the concentration of base by the what? Volume of the base used. So in this case, our Na is just unknown because they did not give us the equation of the reaction, okay? The equation of the reaction was not specified. A monobasic acid is acid that have only one replaceable hydrogen ion. For example, HCl is monobasic. I like your question. HNO3, then CH3COOH is also monobasic because the only acidic hydrogen is this one. I'm pointing. This is monobasic, but H2SO4 is dibasic, okay? H2SO4 is dibasic. Okay, hi Bisola, you're welcome. So dibasic, that is what we mean by monobasic acid. Now, we state this without knowing. Since we don't know Na and Mb, we have already known everything here, which means we are looking for this and this. Do you get me now? So we are going to multiply the strength of the acid, which is 0.2 times the volume, which is our endpoint, which is 25, all over what is our Cb. They gave it to us 0.095. What's our volume? We use 25 ml. Whatever it gives us is our Na and Mb. And when you look at this, 0.2 times 25 is what? 2.5. Divide by 0.095 times 25 is 0.095 times 25 from the calculator department. 0.095 times 25 is 2.37. That's 2.38. Okay, 2.375 or so. So let's see the answer. If you say 2.5 divided by 2.375, 2.5 divided by 2.375 will give us a 2.375. I say 2.5 divided by what? 2.375 is equal to 1. Is approximately 1. 1.05. 1.05. And if you get 1, it means it is what? It means it is a 1. And you know every number on its own is over 1. If I write 2, if I got 2 as the answer finally, it means this is equal to 2. And 2 means 2 over 1. If I have 2 now, it means that the mole ratio of the acid is 2:1. But I got 1 here, which means 1:1. So the mole ratio of the acid to the base here is what? 1:1. All right. So I want to, Blessing James, you're welcome. Please remember to ask questions. I'm going to live stream the experiment immediately I finish solving this question. Then the next one says, I don't know if you have any question concerning the BI. Please learn the procedures. Don't memorize them. Am I communicating? So your own is 2:1. How do we go about that? Let's check the information provided by the question itself. This is 0.2. Okay, yeah. Please, it's not. Yeah. Thank you for that. There is a mix-up there. The mix-up has been figured out. Yeah. Correction is that this is 0.2 times 2.5 is not 2.5. It is 0.2 times 2.5 is not 2.5. That 0.2 times 25 is not 2.5, please. Okay. It is 5. Okay. Don't mind my head today. I realized. So please, I want to make something clear. If you are watching this, please just know that these are not the exact questions you will see in the question paper. So understand the patterns of solving. These are meant to prepare you for you to see the experiment and how to solve the questions. And your job is that you are live. Start asking questions immediately. Okay? So please, for the mistake, we're going to correct everything starting from here. We stated wrongly. What we call this is arithmetic error. This is 5, please, over 2.375, so that our answer becomes 2. And when 2 is there, it is 2:1. Okay? So these are not the exact questions. These are questions that are crafted to teach you what you don't know. We have other many likely questions that I will display, and I've solved it at the Majestic tutorial. So the correct answer, yes, thank you, Ihani Beno. I've taken correction for that. It is not it is nowhere 2:1. All right. So for you, you will watch the SWOT analysis, which is exactly going to be the same thing. Okay. So read the questions very well in the question paper. And we move on. Write the balanced chemical equation of the reaction between A and B. Why you are alive is to ask questions where necessary. Now, we have seen that the mole ratio between the acid and the base is what? 2:1. And they have told us that A is the monobasic what? Acid. The monobasic acid, which is going to be HX. So is HX, and it must be 2 because we have seen 2:1. And then what is the now you can say HY if you like. Then what's the carbonate? They say metallic carbonate. Why can't we call calcium carbonate? Because calcium, the carbonate of calcium is not soluble. So the only soluble carbonate that is possibly used for titration is either potassium carbonate or sodium carbonate, but we don't know. So we can now make it HX because they have told us it's monobasic. Okay, the video will be there, accessible. Okay, HX plus Y2CO3. Yes, that's what it means. Because they said a metallic triazole carbonate will give us what now? Normal. We'll have there will be YX, because that's the salt. This is a metal. The YX plus water plus CO2. All right. So to balance the equation, there should be 2 here, and there should also be 2 here. So, and that balances the equation. Hydrogen will not be 2. Everything will be okay. So you have to infer the equation of the reaction just because of the information given to you. Okay. So please keep watching this. It will profit you, and ask your questions. Even if I have the exact why questions, do you think I will live stream that? No, I can't do that. This is majestic, so we can't do such. Those things you see in the beginning of the video are just to lure your attention to start watching. Okay, sorry if that one deceived you, but this is the real business. If I want to deceive you I'll keep telling you, but you cannot regret watching this video. Do you understand what I'm saying? So this video is well crafted. Be calm and learn the solving. Then I say calculate the mass of carbon dioxide liberated from the reaction. So we can, from the mole, this is 1 mole of this will give us 1 mole of CO2. And they say from the reaction means remember that what they provided for us would have been YHCO. In the exam, read the questions where they can change anything. Your job is to do what? Follow the instructions. Stop acting as if you know anything. You are not supposed to know anything before the exam, okay? For you to calculate the mass of carbon dioxide liberated from the reaction, what you have to do, remember, I'm going to live stream now after I finish this last question. You start seeing now the practical itself, the experiment, for those that really want to learn science. Okay, now we say calculate the mass of carbon dioxide liberated from the reaction. So what is the mass of carbon dioxide liberated? You go back here and pick the equation. From the equation, Y2CO3 will give us 1 mole of CO2. So 1:1. And now they are asking us, this was given to us in mole, and we are looking for this in mass, which means 1 mole of Y2CO3 is going to give us 44 grams. 44 grams is because of what? 44 grams is because of the molar mass of carbon dioxide. So molar mass of CO2 is 44. Carbon is 12. Oxygen is what? They will give it to you towards the end after they have finished asking you those questions. Okay. So when we have this, what we do? We have that 12 plus 16 times 2 will give us 44. So that's how I got 44. Why did I use 44? I used, why do I use yes, 44, because oxygen times 2. Now, we move 1 mole of Y2CO3 gives us 44. Now, you go back. What is CB? CB is the concentration. And CB is automatically what? 0.09 what? 5. So 0.095 mole per dm cube. Mole per dm cube. This means that this is in 1000. So dm cube means 1 dm cube means 1000 cm. 1 dm cube means 1000 cm cube. So 1000 contains what? Contains 0.095 moles per dm cube. What is the volume used in the reaction? Be careful. They say from the reaction. Some people might misunderstand this. In the reaction, what we used was actually what? We used nothing but 25 cm cube of B and also 25 cm cube of A. So please, you now ask yourself, 25 cm cube will now contain how many moles? Or you can convert this thing. Okay, yes, that's normal mole. 25 will contain what? 25 will now contain, I want to finish it up here. You say permit me to move the solving. Okay, I can continue the other way. So 25 will now be what? Will be 0.095 divided by 1000 times what? 25 over 1. All right. So now we have that 0.095 times 25 divided by 1000 gives us what? X. So from the calculator department, 0.095 times 25 is 2.34 on the approximate. So divide by 1000 is 0.0024 or 237. So we have 0.0024 moles. All right, you go back and say that 1 mole of Y2O give us 44. What will 0.0024 mole give? That's the answer. So remember to understand questions before you give their answers. 1 mole of the Y2CO3 will give us 44 grams. And then what will 0.024 give? X. You find that. So now we are going to go live. Now remember to get the salt analysis question. Look at the salt analysis question over here. You visit Majestic Tutorials. This salt analysis, follow the rules. After the live streaming of the practicals, I will now discuss the other likely questions and attend to your own questions equally. Okay, so think let's do the titration between sodium, hydrogen, carbon 4 and then the HCl over here. Remember, we will see the endpoints, but there is no best endpoint range. It depends on the strength of the acid you have. I said it last time. So if you haven't watched it, I prepared. Of course, some of those questions will come out. Solution. Thank you. Some are confirming that in biology that most of the questions came out. Yeah. So, but it's likely questions. All these things we are doing now. This is Sam Majesty's World Science Channel. We are into the real analysis. Just watch well, and then ask your questions. Do you understand me? Thank you. I appreciate you too, my dear. So keep on watching and ask questions. That's why I'm here. I'm not really here for the malpractice in sense. I am for science and to help you in your education. I'm not going to give you fish. I'm teaching you how to get that fish by yourself. So please endeavor to share this video. Whatever you see in the beginning is just to lure you to start watching. Okay, that's business. That's what we call thumbnail. God bless you. No verse too much if the team verse you. Okay. Also watch it. This is showing the endpoints from. Don't worry about it. Okay. The white star is to observe the color change well. So I have to discard this. Alright, here is my A. That's the acid. I think okay, we pray. Just listen and learn. This one, salt analysis must show, for sure. So try to go to the Majestic Tutorials. This thing I'm displaying here is to show that this is science channel, not exam channel. Please watch and learn science. You will learn a lot there. The analysis itself, okay? Gentle will be well done. That won't kill you, so. Adepoju, thank you for recommending. Thank you. I have to fill to 0. after this titration, I'll just do one titration and salt analysis follows live. You will now start watching the salt analysis. After which I'll now solve other likely questions. Eh? You can use either the pump or the filter to get the waves which are filled in the rest of the diagram. Can use this pipette filler or pipette. Can equally use this pump. This one is a bigger pump. Don't worry about what you got. I've said it earlier that there is no best endpoint. Why? Because the strength of the acid varies. It's not the stock solution my school have. It's also the stock solution you will also have. Okay? So just make sure that you are concordant in your titration. Okay? So we don't suck acid anymore now. In the modern age, okay? We use modern things. And remember, these things are available for sale. Okay? Okay, for practical physics, okay, I will not, I'm not too good with physics, but chemistry, biology, anatomy, biology related, I can do most of the physics research experiment, but not the common WAEC things, okay? Okay, the phone is not straight, but I think it's straight now. So let's the chemicals will be prepared for you by your teacher. Nothing concerns you except to go there and do your experiments. That is a bigger pump, it's available for sale. Also with this. So we go on with our titration. We look at the initial still now, what about the choice of indicator to be used in this titration? It is methyl orange and not phenolphthalein. The phenolphthalein will still remain colorless in sodium bicarbonate or very slightly pinkish, which is unstable. So I've done the titration. So I hope we can see that. So phenolphthalein is not the best indicator, okay? For this titration, for somebody asking it, rather the best indicator there is methyl orange. So if I've done the titration and I got to 5 or something, so if all things being equal, what I'll do is to open this tab since I've done my first titration until it gets to close to maybe 23. So if you are looking at that solution, it is as if it has neutralized. But it has neutralized. When I shake it, say it turns all the way back. So it turns again. I'll now trace by adding drop because I'm close to the end point. Remember not to remove it. Don't remove it from the mouth. What I mean is that don't bring it out and shake outside because there will be drops. And if anyone drops out, it is no more part of the molecules used, or the most used, which will lead to error in your endpoint. Okay. And then, I'm looking at this. This is exactly 25. I think maybe I can use my camera here and capture it from this side. All right. You will get enough time to titrate. Somebody say you won't get enough time. Says who? You will. It depends on your practice. Now listen, see what you're gonna do. See my advice. You do your first titration, which is that rough. That's the importance of rough. Please, if you're online, you listen well. That rough is the hardest titration, and immediately you finish with the rough, other subsequent titrations are way too easy. And to meet up with time and become modern, to become civilized, you see gadgets I'm using. I supply laboratory equipment and reagents. These things you don't waste time pipetting base, drinking it, enjoying your secondary school, shouting Holy Ghost fire, spitting it. No, you can't do that. Understood? So what I'm going to do is if you do your first titration, like now I got 25 or 24.9 from what I'm showing you there. Hope you can see that it is 24 point. Maybe I play it so you can so I think it's clearer now. 24.9 is the reading. My subsequent titrations, I don't need to go and waste time. Like when I add 3, I start shaking again. No, this 24.9 has told me, it's already giving me the clue where the end point is. I hope we can see well. This is what we read as 24 point, is almost 24.8, but that's why we have plus or minus 0.1 error. Okay, so don't write, never you read 24.85. No, we cannot read that with this calibration. So hence I've gotten 24.9. In my subsequent titrations, what will I need to do? I'll just open this. Since I know that this titration is reliable, I'll open the burette until it runs down to what? 22 at least. I'll now start tracing the endpoints gradually, drop by drop. Understood? So I will. So some of you getting larger endpoints. I have not seen anybody ask question. I will settle you if you ask question. Why is your value too high? Some are getting 40, some are getting 35. Imagine. So there are reasons, and these are one of them. One of them is that this is the reason why you should buy from Sir Majesty Easy World. So let's play on. I think I've answered you to manage time. The first titration is the hardest titration. Okay, that's 24.9, and I initially got 25.1. So please, I hope the view is okay for those online. The view, are you getting it well, or should I adjust the camera? Yeah, 4 titrations or minimum of 3 titrations. Rough first and second. That's what I said. Rough first and second. I hope the view is enough. Can we see everything? That means I think I got to check the view. I forgot to hotspot this. Should I shift it left or right? Is it now full screen? I want to know the actual view. Shifting it towards this place. I'm pointing towards the box you're seeing, or should I shift it towards me? If you're online, you say so that we can have a better view. Is it showing half a... Are we having full view now? I believe. Okay, I should shift it towards the box. That's like this. Think we can now see the full view now. The full footage is there. Somebody have asked that question, is it a must to do rough? I wouldn't say yes or no, but there is no... When I go through the WAEC marking scheme, I did not see where they say... They just say your table must not cancel, but I'm advising you do your rough, because rough is even important. So do your rough, please. Include it in your table, okay? Because practically, I should tell you yes. No problem. I'll post that, Godwin. Just know that this is a guide, though. So read the questions well in the question paper. The next thing is we are going to look at the salt analysis. I'll be analyzing mixture of actually salt analysis. Rather, I'll say qualitative analysis, because glucose is not a salt. So although we honestly call them all salt, the phenolphthalein is not a suitable indicator. So let's put this aside. Going to our salt analysis. Don't use rough in calculating. We'll be analyzing this mixture of glucose. I have it here in the specimen bottle. The possibility is that the first thing is that you might be told to let me start with that. You might be told to carry small sample from D with the help of the spatula and hold in a non-luminous flame. So over here, so I have my non-luminous flame, and this is C. It's a mixture. Okay, we are back. Maybe I'll take this one. There we go. See that? It's giving us a bluish green flame. I have blocked the air. So you see that bluish green flame, or you say green flame, that suspects, or you say copper. Wait, please, let me check if I can connect. You see, so it is connected already, so I can divide the screen and now see the... So white pale green is for barium. So barium doesn't alright. So be careful. So that you don't stop the whole thing, like I just did now. I'm trying to make it very obvious for you to see. Nice wallpaper. See finish be that. Come on, they like chemistry. What did they do with my wallpaper? Yes, they give mark based on the accuracy of your titer value now. How it agrees with that of your teacher. AC and Emmanuel, you're correct. The accuracy is that precision, how it agrees. If it is, let me explain something. I have to pause the video and explain something, please. There is, if your endpoint agrees with your teacher within plus or minus 0.15, you have 4 marks, 4/4. If it agrees within your teacher's titer value of 0.2, you have what? 3 marks. When it agrees, that's if it varies within 0 plus or minus 0.3, you have what? 2 marks. When it varies within plus or minus 0.4, you have 1 mark. How about when you are 0.5 away? My dear, congratulations, you have 0/4. Do you understand how it works? This is how the accuracy, it is your teacher's report. So you need to learn how to do your practicals well so that you don't vary so much. What does this mean? If a teacher records 24.50 as the endpoint in the report form, when marking you, they see your own averaging and you have 24.60, you will have 4/4 because this is still within 0.1. Am I talking to somebody? Then what if somebody decides to record 24.90? Are you saying that this is 0.4 away from the teacher? The teacher's own is 24.50 and the person is now getting 24.90. This person will have 1/4. What if somebody decide now to have what? 25.00, but the teacher's record is this? You will have 0. This person will have 0/4. So, but remember that when you don't get the concordant titles, you will still lose another mark. Even when you are close to the teacher, in your table there is no concordant title value, automatically you lose this mark. Okay, keep the questions coming, guys. Hit that like button and share this. So if you are deceived by the thumbnail, please know that this is just final revision to help those that couldn't do this experiment in their school and also answer some of your questions. This is Her Majesty's World Science channel, and chemistry is all about science. Okay, so this is how the accuracy of the titration comes in. All right, let's go back to the real practical. Green is a very simple test. Yes, now tell me Olaolu, sorry I didn't get in. You must titrate by yourself now. Will I come and titrate for you? You are the one that will titrate by yourself. Okay, for the phenolphthalein, you can't use it as the indicator. As you have seen here, this is phenolphthalein. Like, take it to this acid. We saw it consumed about 25. But if you use phenolphthalein, Francisca, you're welcome. Or franchise. Sorry, franchise Dixon. I indicator here, but I want Stella to measure. Thank you. Welcome. To measure 25 from it because this was just added. For striking rough is, I can't tell you yes or no whether you strike it or not. I didn't see such rule in the. I did not see any rule concerning that in the marking guide. So, but we are now doing. Look up here. I'm trying to prove why methyl orange is not the suitable indicator practically, because this is Her Majesty Easy World. We handle science, nothing but pure science. So watch it now. It's not all about your teacher told you. Come and see it. When we use methyl orange, we already know that a titration between strong acid and a weak base, we use methyl orange. That's the suitable indicator. Strong acid, and not even strong acid, you just say strong acid and triazocarbonate 4. Also methyl orange is the best because of the pH transition range. There is what we call pH transition range. So sorry I stopped the source analysis to show you why phenolphthalein is not the suitable indicator. This is the solution B, which is sodium hydrogen triazocarbonate 4 containing 8 grams of the salt per 1000 cm³ of solution. If we carry this to this and do titration, remember with methyl orange, our endpoint was 25, at least 24.9. It reached about 20, but do you know, shockingly, let's see what will be the endpoint now if I use phenolphthalein. So the endpoint will be incorrect if you use phenolphthalein. So the most stable indicator in this case is methyl orange, because it's a titration between acid and tricarbonate. So it's a titration between acid and triazocarbonate 4. Do you understand me? That's the reason you give them. And in this titration, the suitable indicator to be used is methyl orange and not phenolphthalein. Or more scientifically, you say because of the pH transition range of the phenolphthalein is not suitable. Okay, you're welcome, Mohammed. Thank you. Just know that this is a guide. You're welcome. And because of the pH transition range, the best thing to use is what? Methyl orange and not Daniel, welcome. Daniel Donaldson, you're welcome. Best of luck in your exams. Focus and ask your question. Okay, if I didn't welcome you, just know you are the most welcome.
Alright, so this is 25. Any other thing remaining is excess. I'm using all the excess bills.
You can be shared in groups during the titration depending on the reagents available and the resources your school can provide. Okay. The idea is that it is each student according to WAEC instruction. Okay.
So my initial here is still 25. 24.9 and it never changed. So initial 24.9, let's proceed. You see? It's already colorless. And this is just 29.5. So 5 to 29 is 4 point something, if I'm right. So you see why the Matthew orange is not the suitable word indicator. So I'm using this to show you practically. See where the liquid is. That's 29.
Are you seeing the endpoint after I used phenolphthalein? It started from 24.9 and is now in 29.
5. That sounds right. Yes.
So I have to go back a bit.
You see why the Matthew orange is not the suitable word indicator.
Wilfred, what's your question?
I'm using this to show you practically. See where the liquid is. That's 29.5. That sounds right.
Sure, the video is here for you anytime you come back.
So that's why
I want to pause this for you to see the endpoint. Yeah, you see when I use phenolphthalein, my initial was 24.9 and just see what it consumed and it neutralized from 24 to 29.1. You see it, that's why it just consumed about 24 to 29 is small. It consumed very small. So why? But from practical experience, what's your question? Ask that question again. So it consumed just small amount, but if you keep it, from experience, it turned colorless. But if you keep it, the phenolphthalein will still come back. Imagine. So it's not the suitable indicator. Okay.
5. That sounds right. Yes. So
you will perform 2 experiments now, which are the salt analysis and the titration. That's the titration is what I'm showing you. I've solved the likely questions or the way you to handle your titration questions, but follow the questions in the actual question paper. Remember, you come back here for us to do corrections after the exam. Then after the titration, we
that's why Matthew orange is the best indicator in this titration, and phenolphthalein is not the suitable word indicator. Okay, continue with the salt analysis. This is the first thing we must be required to do. Another compulsory thing is that we are going to carry out solution that's test for reducing sugar. Glucose there is a reducing sugar.
Tracy, thank you. You are learning a lot. Thank you for being there. That's why I'm here. I really appreciate you for appreciating me. It is God's gift. And I pray we come out in flying colors as we gather here. Bamidele, was that your question? You did not. Time we used to type that, you are not answering me. Just say the question.
One might suspect silver mirror test, but I tell you what, it's not likely going to occur. Silver mirror test might not occur. Remember, we can use Collins reagents or Felling solutions A and B to confirm reducing sugar, because glucose is an aldose sugar. In your exams, they might ask you what's the functional group responsible for the reaction observed when a glucose reacts. No, right, which when we test for this might not occur. Remember, we can use Collins reagents or Felling solutions A to confirm reducing sugar, because
So the reagents used for testing for reducing sugar, Felling solution A and Felling solution B. Then Tully's reagent is here. So somebody say, no wonder you are doing this in class today. Just here discussing the science and learn it, please, okay?
glucose is an aldose sugar. In your exams, they might ask you what's the functional group responsible for the reaction observed when a glucose reacts with this one might be number 3 question. When a glucose reacts with a reducing agent, when a glucose reacts with a mild oxidizing agent like a Felling solution, the functional group there is CHO or HCO because of the extra H. So alkanals are perfect reducing agent, and glucose is an aldose sugar. Because it's an aldose sugar, we call it a reducing sugar. So I'll be needing my Felling solution A and Felling solution B. I'll be making my Felling solution B here. In making Felling solution B, you need a sodium potassium tartrate, sodium potassium in alkaline medium. So I have, this is my sodium potassium tartrate, and remember I produce all these things.
Now, Felling solution A and B, you see, this is Sam Majesty's World Science Channel. I'm going to show you how to produce that A and B, especially Felling solution B. Felling solution A is nothing but just copper tetrahydrosulfate 6 solution. So we learn easy work. Now you use school by these things and it might not be giving you results. I'm producing my own Felling solutions right here, and I will use them to test for the glucose. So you can also learn above the idea of saying what your teacher said. So science are meant to be done and not to be memorized. Okay, that's why Sam Majesty's World Science Channel is here. Remember, for you to get the report on this salt analysis, to get the detailed reports, that is test, observation, and inference, how you are expected to write them, you visit my new channel that will handle tutorials. That is Majestic Tutorials. That video is already there waiting for you. Just you see the exact thing you need to know, how to report them, the salt analysis. So see you there.
So you can put place order for yourself. I want to do it for you to see, because though solution B, first solution B is a bit more expensive than Felling solution A. I think this acid I want to make Felling solution B here. This is my A already, which contains copper 2 ions. Copper 2 ion is a mild oxidizing agent which will be reduced to copper 1. Copper 1 is responsible for that color. Normally, you need to measure about 173 grams of sodium tartrate, and then about 100 grams of sodium hydroxide.
Okay. Let me pause and visualize how this appears on the screen. Let's check if it is perfect.
Smart Balance Oil is rich in gamma-oryzanol, may contribute to the reduction of bad cholesterol. Smart balanced oil is rich in gamma arsenite, may contribute to the reduction of bad cholesterol. Smart balanced oil is rich in gamma arsenite, may contribute to the reduction of bad cholesterol.
Okay, you're welcome back. I couldn't even fix much because the adverts keep replaying.
Is expensive. Is acting as a chelating agent, which they might ask you what's the functional group responsible for the reaction observed when I'm filling solution B. I'll be making my filling solution B here. In making filling solution B, you need a sodium potassium tartrate in alkaline medium. So I have, this is my sodium potassium tartrate, and remember I produce all these things. So you can put all that place. I want to do it for you to see, because those solution B, very solution B here. This is my A already, which contains copper 2 ions. Copper 2 ion is a mild oxidizing agent which will be reduced to copper 1. Copper 1 is responsible for that color. Normally, you need to measure about 173 grams of sodium tartrate, and then about 100 grams of sodium to keep it alkaline. But because I've been doing it for long, I don't mind. I will make it free. But this is
Aluko Samuel, thank you.
It's expensive. It's active.
So to prepare filling solution B, you need sodium potassium tartrate. That's what I have there. Sodium potassium tartrate. So you listen well.
As a chelating agent, that's what we call chelating, meaning it acts as a ligand to bind the copper 2 ions so that it will not go and react with the base to form copper 2 hydroxide, which we when we test for copper 2 ion with sodium hydroxide, gives us light blue gelatinous precipitate. But this sodium tartrate is what? Is a chelating agent, meaning it forms ligand with copper 2, holding it from reacting with the sodium hydroxide. And the sodium hydroxide provides the alkaline medium needed to make the reaction proceed. Alright? So, I'll add water now and mix. So, over here is my filling.
So I'm making the filling solution B by myself, and the A is already there.
B, this is A, this is B. Remember, it is highly soluble, so soon dissolve. Now, I'm going to...
Okay, the functional group in that salt that gives it its function is the HCO. HCO, that is, in the arcanone, glucose is an aldose sugar, meaning it has aldehyde functional group. So we call it aldose sugar. And it has the functional group C double bond O with extra H attached to it. So this extra H attached to it makes it a reducing what? Agent. So the glucose is the reducing agent because it has extra H. So the functional group is HCO or H double bond O. Unlike alkanones just have C double bond O without any extra H. Do you understand me now? So without any extra H. So alkanones like fructose are non-reducing, but glucose, which have this extra H attached to the alpha carbon, is a reducing sugar. So you can watch my video here on what? Saver mirror tests on this tests for reducing sugar. There are many here, but you only come to watch when it is yes, thank you, Zainab. We have corrected that. Is 5 and not 5. My error. Okay, you're welcome.
Remember, you'll be told to dissolve with water and divide into portions. So this is my sample C. I'll collect more. Remember, it's qualitative analysis and not quantitative, meaning it doesn't respect quantity, but it just respects the presence of the ion we are looking for. So you add equal amount of Fermi solution A and Fermi solution B. You might be told to add only B that day, you will get the same result.
You add equal amount of Fermi solution A and B, they will give you volume. And don't be surprised if they tell you to add only Fermi solution B. Why? Because the mixture already have Fermi solution A, which is that copper sulfate. Copper sulfate is Fermi solution A, while Fermi solution B is sodium potassium tartrate under alkaline medium. The pH should be close to at least 11 and above for the reaction to be effective.
So I think, let me try. Let me start test tube holder. Alright. You might be told to not to even add A again and just add B. This is B, equal volume. Okay, you see, we stop the precipitation. This is sodium hydroxide added. If it is only sodium hydroxide, you see pale light blue precipitate, but there is no precipitate, so it is the sodium potassium tartrate that is holding it, stopping it from forming a precipitate, so that the copper 2 ion can be reduced to copper 1 by the glucose. Alright? Remember, it's just warming. You warm gently, the reaction is already showing a positive result. Okay? It gives us a yellow or brick red precipitate. You have to warm and keep it calm, so the color will be very obvious. You see? The result is not actually so fantastic. Okay, yeah. This brick red precipitate here it has formed. The B is so much concentrated. So I think.
So you see, it has given that brick red precipitate or orange red precipitate. So it means, and it's very, very effective and sensitive. So I was able to make the solution A and B by myself. That's the additional thing you got to learn. Now, let me discuss some chemistry here for your own benefit. The reducing agent here is the glucose, and I've explained it earlier. Then what's here? Copper 2 ion is the oxidizing. Okay, you're welcome back. What I was explaining, the oxidizing agent there, the copper 2 ion is the mild oxidizing agent, while it is now reduced to copper 1 ion. So what reduces it to copper 1 ion? Glucose, and that's why we call it the reducing sugar. Okay, so now in this sense, this is blue in color, while this is what? Orange red or brick red. That's copper 1. That's orange red. So the glucose reduces +2 to plus what? 1. But it requires what? A chelating agent, copper 2 ion. This process, remember, redox reactions usually happen in alkaline medium or in what? Usually happens in alkaline medium or in acidic medium. So this process requires an alkaline what? Medium. And the alkalis used here most times is sodium hydroxide. Now, guess what? If you add this sodium hydroxide, all right, so the copper, the alkaline medium now is what is needed to make the reaction proceed. But if you mix it, it will react copper with copper and form copper 2 hydroxide. That's why then the reaction needed to introduce something that will hold. Remember, copper 2 ion is a transition metal that forms complex ion. So this copper 2 ion now form complex ion with the sodium potassium tartrate, which is now a chelating agent. That is the agent that forms what? Complex ion in the presence of a coordinating metal, that's a transition metal. So the sodium potassium tartrate holds the copper 2 ion, preventing it from reacting with the sodium hydroxide so that it can be reduced by the glucose to copper 1. So the brick red orange color, they might ask you what is the ion there? Copper 1 ion. But what's the ion in the blue color? That's copper 2. Remember, if you add all these things and warm and there is no brick red reducing agent absent. Now, what is the product that the glucose is reduced to? The glucose is reduced to gluconic acid. So because the glucose is oxidized. The glucose is oxidized to gluconic what? Acid. As it is reducing copper 2 to copper 1, is oxidizing itself to what? Gluconic acid. So remember, there can never be reduction without subsequent oxidation. If copper 2 is reduced to copper 1, something is subsequently oxidized. So gluconic acid is the oxidative product of glucose from this type of what? Reaction. So you can imagine this now. Remember that the functional group is HCO3. Then you should know the other isomers of glucose and other possible reducing agents. All right. This is Her Majesty's World Science Channel. Please subscribe and share this video. Like this video. Give this video thumbs up if you have learned anything from it. So let's continue.
Precipitate. Yours may not give you this because you are not using the original one. I just prepared mine now. And I've added more water to lessen the strength. Then you repeat. So that brick red, as you are seeing, it is copper 1 ion, while the blue is copper 2. So glucose is a reducing agent that reduces copper 1, that reduces copper 2 to copper 1 ion, alright? But it needed to be held together under alkaline medium. What is holding it is a sodium potassium tartrate, which is bidendate ligand. That's what we call bidendate. EDTA will not work well here because EDTA is a hexadendate ligand. It has 6 of them where it can bind it. So it will bind the copper strong that cannot even release it at all. So that's why EDTA is not suitable here. Where is my sample? C. It's over here. Become more clear. The test and everything, I have the written form of it where you can access the test will be sample C, or first portion of sample C. But you know that there should be your report will be exactly what? The test and everything, I have the written form of it where you can access the test will be sample. C, or first portion of sample C, plus filling solution A and filling solution B. They will tell you amount to measure. The reports will be there comprehensively. Now just say formation of Greek red precipitate. That's the observation. Inference. C, or you say presence of a reducing sugar or presence of glucose, or you say reducing sugar present, glucose present. All right. So the next part is that we might be required to add barium chloride to a portion of C. So I'm collecting small portion of C. Remember, you'll be told to dissolve the remaining part after you are done with your flame test. These are the likely questions, of course, not the exact thing. So your job is to listen well and see the procedure. So I'm going to, what I'll do now, I think I'll dissolve the whole. Oh, exhausted, but this is enough. And from here, I'll now be collecting samples to do the rest of the analysis. So this sodium, remember this is my sample C remaining. I think I'm stopped here because I'm about to finish everything. So, but thank God I'm a good manager. I will manage it. It's called qualitative analysis and not quantity. It doesn't depend on size. So the second portion, first portion, third portion, depend on how the question. Remember, you're adding soda dioxide to the sample C. I'm adding. You'll be told to add the drops and the excess. Here I need
Please, the initials must not be 0.00. 0.00 is when you fill to the burette, like you fill it to the 0 mark of the burette. But if you fill to 5, you write your initial as 5. Thank you guys for liking. I so much appreciate you guys. Thank you also. Then endeavor to share this. Come back here so that we'll discuss the exam. After everything, we'll take correction. I cannot do without you guys. Much love. Stay majestic. Keep bringing the question as we move on. Please. During the titration, why you see some rough that is not 0.00 is because they did not fill the burette. Initial means where is it, the mark it is before you start titration. Then the mark where it stops after titration is your final. Okay, it's just like where are you before you start this journey of life. That's your initial point. Then you now later became a billionaire tomorrow. That's your final. Do you understand that? So initial of everybody must not be the same. But why do we usually make it 0.00? Because of the fact that it will reduce what we call AE, arithmetic error, because you might make your initial 5.1 while doing subtraction. You make mistakes and you lose marks for that. Thank you guys. Keep hitting the like button and subscribe to this channel, please. Much love from me to you. Let's continue.
Control this drop question in terms of purity. So you add in drops. I think there is a light blue gelatinous precipitate. We never observed anything like this when we added filling solution B. Why? Because of the chelating agent that held the copper 2 ion from reacting with sodium hydroxide. Sodium hydroxide is just to maintain the pH. That's the reason for filling solution B. Okay? I'm adding now in excess. Something is wrong somewhere. It's supposed not to dissolve in excess, but fortunately it's dissolving.
23.733 as your average data is not bad at all. It depends on how close, and it's not bad. It's like I said earlier, stop these theoretical manipulations. Understood? Examiner is marking is how the teacher and the student rhymes in their values. Do you understand me? But we often manipulate in order to suit the question in the question paper. Remember, as a chemistry teacher, you are not allowed to see the question papers if all things work out well. So what are you doing with their question paper? Are you a student? Can you be student and be a teacher at the same time? Play one role, my dear. Okay?
I have to. So thank God I have sodium hydroxide. Which one was that? Okay, this was the.
For the salt analysis table, visit Majestic Tutorials. That table is already there waiting for you. All right, we are back.
I'm making my own sodium hydroxide to know where the error is coming from.
So did you notice what is happening here? With sodium hydroxide, we are encountering something strange. This is where I don't know what I'll tell you. See, I added sodium hydroxide in drops and it formed light blue gelatinous precipitate, but in excess, it formed deep blue. I don't know if you are following this live stream. It shouldn't be, and it dissolved. So maybe because of the glucose interference. And the question is why? I doubted the sodium hydroxide that I already made before in the lab. I'm now making a fresh sodium hydroxide to confirm if this is true, because it's real.
Okay, now, fast and furious. Be careful with sodium hydroxide. It's corrosive when concentrated and in solid form. So I have my probe. To close it because it's a daily percent. Collecting small portion.
So I've made my fresh sodium hydroxide. Let me know where the error is from.
Alright. This is my sodium hydroxide. The same thing. Is it the glucose that is interfering with it or what? It is all we know to form a deep blue solution. It's interesting to know. And if I didn't do this, I will report persist in excess. It's dissolving. Let's try with ammonia. Because we'll find out.
Chimdin, you're welcome.
Why such happened. But this is the reality. Dissolves in excess sodium hydroxide. The question is, what are you going to report now in your observation? So I am happy doing this. It's becoming more interesting than I ever imagined. So I'm going to use aqueous ammonia. In drops and in excess. Here is qualitative analysis. I'm going to be really stingy with these things. Okay. I think I'll carry this one. You can use dropper if you are not precise enough, but if you are, you can use freehand and drop. So in drops, it still gave us white and light blue. It's gelatinous, although it's sticky to the walls. When I shake it, you see, it can remain. If it is powder, all of them. In excess, still dissolve to form. The game is becoming more interesting. This one has turned
So watch here. This is a common challenge. You see, the sodium hydroxide that formed the light blue precipitate in drops and dissolved in excess to a blue solution is now turning a bit greenish and having the even orange. With time, when I left it, it started turning orange or brick red very slightly, just like you are testing for glucose using Ferlin solution A and B. So what could be the problem here? Maybe the atmospheric oxygen is oxidizing the glucose to gluconic acid in that alkaline medium. So maybe the sodium hydroxide just provided the alkaline medium needed, like I said earlier. So I wouldn't know if WAEC brings out the sample plus sodium hydroxide in drops and in excess, what are we going to report? If you have done this experiment, you have faced that same challenge. And my own predictions is that the reason react.
least I've turned back to insoluble copper hydroxide because precipitate has formed, but it didn't form when I added in excess. Okay, they better not ask this one, but we'll go through that. I think we are going to expect add sodium hydroxide in excess and keep. So you report dissolves on adding, then bluish green precipitate reappear. But when we keep both, remember this was with the Felling solutions A and B, brick red, orange, red precipitate. So these are the three possible colors we will see. If I added enough copper 2 ions, this would be very deep blue, interesting, but I wasted a lot of my sample C. But I still can get small parts. So now for silver mirror test, let's check if it is real. In silver mirror test, you need silver 1095 solution, aqueous ammonia.
For you, report form, teacher's report form, you comment down there after the whole thing. I'll give you a link of the video you watch to know how to fill the teacher's report form, okay? Thank you for joining my live stream.
Sodium hydroxide to prepare Tolling's reagent. So, but because of the presence of some interfering ion like the copper 2 ion, the positive results might not be as clear as expected. So that means, I think this my sodium hydroxide is doing well. It's not no fault for me. I want to
Solomon Ugwai, thank you.
tap more of this here. Alright. Now we are going to test silver mirror, whether silver mirror is going to be possible or not. But theoretically, it will not work. Another possibility is to test the solution with litmus. I'll test it with litmus, but based on salt hydrolysis, mixture of glucose and copper sulfate 6. Glucose is neutral, of course. It doesn't even ionize the water. It doesn't release any ion. But copper sulfate 6 ionizes to give copper 2 ion and the sulfate 6 ion. The sulfate 6 ion come from H2SO4, which is a strong acid. Copper 2 ion come from copper 2 hydroxide, which is a weak base. So a salt of strong acid and a weak base will behave like an acid. So definitely the solution is expected to turn the blue litmus paper red because it will hide.
I say you can search Majestic Tutorials to get that video. Search Majestic Tutorials channel, you get that video, or go down to any video in this channel, you will see the link. It's a new channel I created. I'll handle theoretical work, while here focuses on the experiment, because this is Her Majesty's World Science channel.
The water to give an acidic solution.
The link comes after I'm still doing the live stream. If I'm not on the live stream, I would have given you the link.
Reason, because it is a salt of strong acid and weak what? Base. H2SO4 is the acid, while copper 2 hydroxide is the base. So that's the case for litmus. So let me proceed to is the original sample. Let me add to it again.
The 25.3 in the rough, I didn't get it. Because it's rough, it's a manipulation. I added any number I liked. I've forgotten the rough I got when I did the titration. I clean everything. Remember to reduce contamination. You have to wash the burette with the acid. If you wash it out, fill it and wash it away. It's a way of reducing contamination.
I want to introduce more of the seed. Yeah. In Tolling's reagents, that is what we call a silver mirror test, you'll be required to add sodium hydroxide first. But just like I told you, if we add sodium hydroxide, then followed by, we are going to add silver nitrate first, followed by sodium hydroxide. So I'm making my silver nitrate here. Silver nitrate, the original one, is quite expensive. Always store in a dark bottle to prevent interaction or interference with light.
So let's save ourselves time. Silver nitrate, the titration is not, the experiment is not feasible, meaning we can't have the Tollings reagent like test, silver mirror test. Silver mirror test, I don't see the possibility. So it's just because silver nitrate is there, sodium hydroxide is there. So if you do it, the copper 2 ion will be interfering, okay? So that's, and you watch my video on that silver mirror test, maybe I can show you how it looks. You comment, it's already a video that some years ago I did the silver mirror test. That's what I'm trying here, but it's not working out because of the interference by copper 2 ion. So the last aspect should be testing the solution with litmus. You're required to test the solution, the mixture with a litmus paper. Because of salt hydrolysis, it will have effect on what? We have a mixture of glucose and copper 2 sulfate. So this is this level we are now in the testing.
Use both red and blue. If it doesn't have any effect on both, you now say no action on litmus. But if you expect them to tell you the one you use, they are giving you the answer. If they say use blue, you're expecting something to happen on blue. So here is bluish, the mix of color item blue. You have to blue. So I'm using blue. Okay. I think it's giving us that. It's turning green there. It turns blue litmus paper red as theoretically expected. It's giving us the result positive, practically also. I think this is obviously blue. There we go. Bam. It's very quick in action. So it forms blue litmus paper red. You say solution C is acidic. Alright? They've been saying use litmus. So even if they say tap small and add any indicator, just know that it's going to act as an acid. Alright? I'll keep this because silver mirror will take time to form on the layers. But if it's going to form, it's supposed to start.
The 0.095 I used was, they can give you any value in the question paper. You use the concentration given to you in the question paper, not the concentration given by me or your teacher or any other person or the one in your brain. Use the one you see in the question paper, okay? So it was the concentration I gave, and actually that's the real concentration of solution B, because it contained 80 grams of sodium hydrogen thiazocarbonate 4 per 1000 cm³ of water, and to convert mass to mole, mole equal to mass over molar mass. Therefore, you will have that mole is equal to 8 over 84. The molar mass of sodium hydrogen thiazocarbonate 4 is 84. So for the strength of the acid, it depends on the percentage concentration of your stock what solution.
Let me introduce more of the glucose. Alright, thank you for watching. Please, having visited this young channel, please subscribe to make this grow. And then expand it by sharing the video. I cannot do without you. Thanks for watching once again.
So the practical is over. Let's see other likely questions that you may encounter. Thus, your job, I will display them for you to screenshot. Okay, here are the sets of likely questions apart from the ones I've seen. I've handled so many of them at the Majestic tutorials. You can snap and get where you cannot go through this. Let me start from number 1. I have a video on that already. So I'm now waiting for your challenges. If you have any problem in the next 5 minutes, you come with it. If not, we are ending the live stream. If you have any question or challenges that might hinder you from doing well in this practical come with the question, whether you are a teacher or a student. So come up with it. I am here for you. Remember to subscribe, please, and share this video. Thank you for joining my live stream, of course. Keep hitting the like button and the share button. This will go a long way to help you. The disclaimer here is that this is nowhere. Anything you see before joining this live stream, it was just to lure you to join the live stream. It's not going to be the real actual questions. Then for these SWOT analysis questions, my dear, the chances are almost 95%. Those things you see is what will come out from the exam. But for this titration, your job is to learn how to do your calculations well, to make your tables and secure your mark. So follow the rules. I've answered the likely question I posted in the beginning. So, and I thank most of you that joined early and were able to share, were able to comment, make it fun and lively. This is Her Majesty's World Science Channel. If you want me to do any analysis on any compound, I'm doing this because this is what most followers wanted now. But if you have any compound you want me to analyze, we'll have a live stream like this and chat. I will be glad. If I can do that, I will do it gladly. And remember that science will change our nation, not certificate, okay? So in that channel, I solved question 1, and I skipped 2 because 2 is similar to what you saw in the beginning, okay? The difference is that I hidden this question 2. They asked the number of moles of hydrogen triazocarbonate 4 ions in 500 cm cube of B. If they ask you the number of moles of hydrogen triazocarbonate, if they say number, not number of moles, they say number and number of moles are not the same thing. So if this question appears, your job is to involve Avogadro's number. When they tell you how many moles, you don't need to involve Avogadro's number. When they say how many molecules, do you understand me? What the number of ions, you have to involve Avogadro's what? Number. So in this case, you have to write the equation about A. Let me solve that number of moles in case if it appears. The number of moles of HCO3 minus. First of all, we already know that the HCO3 minus came from B, which is sodium hydrogen triazocarbonate 4. Remember, they can hide the acid, hide anything. So you dissociate it, it will give you Na plus HCO3 minus. This implies that 1 mole of what? NaHCO3 will give us 1 mole of this ion. And they are asking us the total number. We already know that 1 mole of any substance contains Avogadro's number as its formula unit, okay? So we now say change this 1 mole to Avogadro's number. That means 1 mole sodium hydrogen trioxocarbonate 4 will automatically give us what? 6.02 times 10 to the power 23 number of bicarbonate ions, all right? And then you go back to CB. CB will be given in that question, meaning the molarity of B. And molarity of B is what? The molarity of B. Okay, I will do that. Drop the link for the teacher's report. I will drop it after this live stream. CB is the molarity, which from this question has been 0.095 moles per dm cube. All right, that means dm cube is 1 liter, please. This means that 1000 what? 1000 cm cube, because 1 dm cube is equal to 1000 cm cube, contains how many moles? 0.095. Then they gave us volume in that question. They say the one liberated by 500 cm. Then you now say how many moles will be in 500 cm cube of B. Remember to use the exact volume given to you to get X. So at the end, value of X will be automatically 0.095 divided by 2. That is X is equal to now 0.095 divided by 2 after everything, which from calculator we will have that 0.095 divided by 2 is 0.0475. 0.0475. Okay, that's the number of moles. Then you go back to the statement. The video will be available, of course. Just After any time you come back, you watch it. But remember, these are likely questions and guides to help you. So you now go back to the statement which says that 1 mole from the dissociation of NaHCO3 will give you what? Kinder Emmanuel, welcome. Hi. Hello. Will give us 6.02 times 10 raised to power what? My acid is very I got 14. No, it's not your acid that is the problem. That you're you are not using the wrong I mean, you are not using the right bicarbonate. You are using something else. Check where the percentage, the common percentage of the I produce all this. The common percentage of acid we have in the market is 37%. So how come your own is giving 14? 14 shows that your own is close to 60-70% HCl. Maybe the congratulations. So go back to what I'm saying. 1 mole sodium hydrogen carbonate will give you 6.02 times 10 to the power 23 atoms of hydrogen ion. Then the mole we got here is 0.0475 will contain what? X. Okay, whatever you now get here becomes your answer. Now, how about the general knowledge question, which is question number 3? There are many things they can ask. So even for your theory, read everything about glucose. I am just suggesting, I'm not quite sure. Maybe isomers of glucose, the other test to detect glucose. Then you'll be able to also go through about some practical questions. Why is phenolphthalein not the suitable indicator? Another one is also, you'll be able to know if you pour water, the effect of impurity. Yes, they might tell you that if a boy mistakenly adds, you also learn dilution law very well. If a boy mistakenly adds 5 or 15 ml of water to the measured base, you measured 25 ml of a base and titrated and got an endpoint, and on the second titration, after measuring the 25, somebody mistakenly added water, distilled water to it. What will be the effect of water to the endpoint? Since it's water that is added, remember this, see what I mean? If we have this, something like this is our volumetric flask, and this is where we have our solution A. N with your N means your rage number there labeled on it, and somebody uses now pipette, 25 ml pipette to pipette what? 25 ml of this and titrated. After titrating, he now pipetted again the same 25 ml, and he pipetted 25, first one maybe got 24.90, okay, and again he went back and do the same pipetting. The first titration he pipetted got 24.90. Now he pipetted the second one and added the same 25, and somebody added extra 15 cm cube of water to this, so to this one and not here. So what will be the effect on the endpoint? The effect on the endpoint is what? The effect is that what happens? It will have no effect on the endpoint. The endpoint will still remain 24.90. Reason is because water is neutral. Water is neither an acid nor a base, and therefore is not affected by what? The adding water. But if you add any small base, maybe orange juice, automatically the endpoint will do what? The endpoint will lessen, because when you add orange juice to the titer mixture or to the base before titrating, you are neutralizing some of the bases there, therefore reducing the acid it will consume. So you are lessening the endpoint. It will be less than 24, assuming they added orange juice. Then what if they added bicarbonate there or baking soda? They might tell you after pipetting, a baker mistakenly added baking soda to it. You have added more base. The endpoint will increase from 24 to something to 30, just a number above 24. Okay, so thank you guys for joining my live stream. I wish you guys the best of luck. This brings this live stream to an end. Nice having you guys. Best of luck. I'll be here to discuss the question paper after the exam. Okay.